Hello everyone, my name is Mr. Noah Adekule. Today I shall be taking you through the topic called congruent shapes. I repeat again, congruent shapes. Congruent shapes is more like an abstract topics, but today I will try as much as possible to break congruent shapes down as much as possible. Now when we say a shape is congruent, what we mean is that the shape has almost the same similar properties or exactly the same similar properties. Now let us take for instance this diagram. Now we have a triangle ABC and XYZ. Side BA is the same as side XY because of these three lines. Let's take a look at side AC. Side AC, and considering side XY, SZ are the same. So let's take the last side, BC and YZ are also what? The same. That makes it congruent because all sides are equal. Also again, comparing the angle, this has a code of 3 angles this way, and this has a code of 3 angles this way. When you look at angle C, this angle and this angles are equal. When you look at the third angle, this angle and this angle are equal. So in all parameters, this angle is similar to this angle, exactly the same. So we can refer these two triangles to what we call a congruent what? Shapes, or a congruent triangle. Now let's move on to the next thing. Let's take a look at the next subtopic, which is conditions for naming a congruent triangle. What are those conditions we must put into consideration to name a congruent triangle? Let's take for instance number 1, a side-side condition. What do we really mean by a side-side condition? Like I said in the initial example that was cited, the two triangles are the same if they have all sides, if they have the same exact side. Now what exactly do I mean? Look at PQ and look at ED. Both of them are the same. Also the same way we have QR and EF, and finally we have PR and FD. So in a nutshell, you can easily relate them by writing as QP or side QP or line QP is equals to your line ED. Is equals to, let me call this line ED. Also again, your QR, your line QR is also equals to your line FE. Also the same way, your line PR, your line PR is the same as your line DF. So now we have been able to look at first condition. For you to have a congruent triangle, it must have what we call the side. Means the 3 sides must be the same. So let's move on to the next condition. And what does it say? This time around, the second condition says it must have what we call a side and side. Now what do I really mean by side and side? Like I said, they must all be the same in all parameters. When you look at your side BA, so here I can easily say that your line AB is equals to your line XY. Also the same way, your line BC is equals to your line what? Your BC is equals to your line YZ. And let's take a look at this angle. This angle is in between this single line and this double line. This angle is in between this single line and this what? Double line. That means your angle what? B is equals to what? Angle what? C. And do not forget that if you are to determine this side, since the angle is in between them, you have the same side as that of this. So without stressing yourself, you can easily what? Write this as what? Line AC is also equals to your what? Line S what? Z. And that makes these two what? Triangles a congruent what? Triangle. Now let's move to the next condition. What does it say? The next condition says angle side. What do we really mean by angle side? In a scenario like this, in the case of this diagram, so let's take a look at this together. Now, look at this angle, this two angle, and these two angles are the same. So I can easily refer this to my angle A is equals to what? Angle P. Also the same way, look at this angle, your angle what? Your angle B is also equals to your angle Q. And do not also forget that this is the angle, Now let's take a look at the left side. The left side is what? BC. So we can easily say your line BC is equals to your what? BC is equals to QR is equals to what? QR. Now, having said that, do not forget that if this angle is 40, assuming this angle is 40 and this angle is 50, definitely means that this angle will be what? 90 degrees. Also the same way, if this angle is 40 and this angle is what? 50, so this will automatically be what? 90. So in all parameters, this angle and this angle are the same, 50, 50, 40, 40. And that also makes what? These two triangles a congruent what? Triangle. That makes that a what? A congruent what? Triangle. Let's look at the third condition and the fourth condition. Alright, the next one says right hypotenuse and one side. What does that really mean? A right hypotenuse and one side. So this is what it means. We have a right angle triangle, we have two right triangles, and the question is, are these two triangles what? Similar? Now, looking at these two triangles, okay, this is your what? Adjacent. This is actually your what? Opposite. And this is my what? Hypotenuse. Now, the same thing applies here, your hypotenuse, your what? Opposite, your adjacent. Then let's call this the opposite. Now, having said that, now, since this line, HF, is also equals to NN, your HF is equals to what? NN. And at the same time, your GF is equals to your what? NR. So, looking at this triangle, since this is a right angle triangle, whatever you have here, let's assume it is X, must also be the same thing as what you be having here, using Pythagoras rule. So, in nutshell, your GH is also the same as your what? Your RN. Your R what? N. Since this is angle 90 degree, this is also angle 90 degree. Do not forget that you make use of SECRETE. Whatever angle you have here must also what? Be the same with whatever you are going to be having what? Here. So which will also be the same as what will be yellow called Z. So in all parameters, the sides are the same and the angles are the same. That makes these two triangles a congruent to a triangle. But the name of this the condition attached to this particular triangle is the what? The right angle what? The right hypotenuse side. So we have been able to look at the different conditions for two shapes or two triangles to be what? Congruent. Now let's look at this example together. Let's look at this example together. What does the question says? Decide which of the following pairs of triangles are congruent. and they are not congruent. If congruent, state the condition of congruency. Hence, state all the corresponding sides. So we are going to be taking it one after the other. So let's take the first one, which is the A. And what does A say? Now look at this diagram. We have AC, we have A here, we have C here, and we have B here. Now we have our P here, we have your Q here, and we have our R here. Let's look at the relationship between these two triangles. Now AB is equal to QR. Also the same way, your BC is equal to, QP. Also, when we look at the third line, we have AC and we have PR. We cannot directly say that these lines are the same, because the angle is not in between this double line and this single line. Angle is not here, but rather here. So this, in a nutshell, does not necessarily mean that you cannot ascertain that your AC is equals to PR. This cannot be ascertained, and as a result of that, that makes these two triangles not congruent. So these two triangles is not congruent. So we are done with the first one. And it has no condition because it is not congruent. Now let's move to the second one. Let's look at the next one together. Now let's take a look at this triangle, just like the fourth condition that we just treated. Now when you look at HF, your HF is equals to, it has a double line here, is equals to your AC. Also the same way, your GF is equals to your BC. Now, do not forget that you make use of your Pythagoras rule. Whatever answer you have here must also be the same as what you'll be having here. So, in nutshell, it means your GH is equals to your A B. So, in all parameters, all sides, the triangles are the same in terms of side. But do not forget the rule for when you have a right angle triangle, and this is also equivalent to having right hypotenuse side. So the condition for this is your right hypotenuse and side. This is your right, this is a right angle triangle, this is your hypotenuse, and this is your side, and that is why we call it right hypotenuse side. So let's move on to the next one. Now let's consider these two triangles. Let's see if they two are congruent. Now to start with, we are looking at this now. You have CU is equal to FE. CU is equal to FE. This line is equal to this line. Also the same way, when you look at the positioning of this particular line, it is facing this double angle. When you look at the positioning of this single line, it is facing this single angle. This means there is a true relationship. True relationship between this CU and FE, because it is not facing the same angle. No true relationship between those two lines, and as a result of that, it is not congruent. Now, having been able to resolve that, let's take a look at the last example. And what does the example say? So let's take a look at this together. Now, this time around, we have here to be 4 centimeters. We have here to be 64 degrees, 46 degrees, 70 degrees. Are they congruent? That's the question. Now let's relate the sides together. We have AB as a single line, AB, and QP and Q what? P. AB is equals to what? Q what? P. But let's take a look at this angle facing, okay, AB is 4 centimeter, QP is 4 centimeter. That means that equation is true. Now let's take a look at AC. AC is 5 centimeter and RP is 5 centimeter. It means that your AC is also equals to your what? Your R what? P. So that means this is true. And do not forget that this angle 64 is in between 4 and 5. But when you look at this particular triangle, we do not have angle 64. But we really do not know what is meant to be here. But do not forget that the sum of angle in a triangle is equals to what? 180 degrees. So you can easily write this as 46 plus your 70 plus, let's call this x, is equals to what? 180 degrees. As a result of that, your x is equals to what? 180 minus 46 minus 70. And by so doing, automatically you have what? 64 what? Degree. So in all ramifications, the angles are the same, the sides are the same, because by the time you determine the value here, it will also be the same as the value here. So in a nutshell, this is what? A congruent what? Triangle. The both triangles are what? Congruent. Now we have been able to see that. For more better understanding, okay, let's take a look at this next example together. State with reason which of the following triangles are congruent and not congruent. Now let's take a look at the diagram. So we take one after the other, okay? Let's take a look at this without having to waste much of my time, okay? So we have two triangles. Looking at the triangles, they have equal sides. This has a single line, this has a single line, this has a single line, this has a single line. So in nutshell, it's also related to a what? To an equilateral triangle. So in all sides, so this is what? Congruent. So with the condition side, side, side. And I'm done. Now let's take a look at B. Do not forget that this angle and this angle are the same, this side and this side are the same, this side and this side are the same, and they are having the same common angle. So in all ramifications, are you getting it? So we have this angle the same as this angle, this side the same as this side. So it is equivalent to having an isosceles triangle. It means that for an isosceles triangle, the base angle must also be what? But the same. So as a result of that, this is also what? Congruent. This is also what? Congruent. You have your side, and you have the angle in between this what? The two what? Line. So we have the side and the what? Side. Now let's move on to the next one. Now, we are looking at the next one. We have a right angle triangle here because of this particular what? Symbol. But looking at this now, the longest side has a double line, the longest side has a single line. Now, this shortest one has a double line, and this shortest one has a single line. Now, the question is, are these two triangles what? Congruent? Now, we are looking at the diagram again. So, if this happens to be a value, there is a value here and there is a value here. At the end of the day, for you to determine this value, you would definitely not have the same answer as we have in here. Also, the answer between this and this will not be the same. The reason being that if assuming here is 4 and here is what? 5. And this place is what? This is double, this is if this place is 5, if this place is this is double, you have here to be 4. The double is 4 and this is single. This actually is 5. This side is 5 and this side is 4. So in a nutshell, you would never have the same answer as D. So therefore, it is not what? Congruent. And let's take a look at the D part of the question. The D part of the question, what does it say? So let's take a look at this together. This has 3 lines. This has 2 lines, 1, 1. So we are looking at the sides are not the same. So as a result of that, we conclude that it is not what? Congruent. And it has no condition. And let's take a look at the final one, which is the E. And what does it say? We have a single side here. Okay, we have a single side here. We have also a single side here. Do not forget that this single side is facing a single angle. This single side is facing a single angle. So if this angle is 40, here is also 50 here. Placing that under assumption, here will be 90 and automatically here will also be what? 90. In terms of the angles, these two triangles are what? Congruent. But on the other way around, if you also determine the value on each side, you will also have the same what? Value. So that makes this what? Congruent. And that is what congruent is all about. Thank you for watching. I remain Mr. Moadalda Adekunle.